Welcome to Behind the Science, where we ask challenging questions directly to the scientists who are trying to solve today's toughest problems. I'm your host, Jennifer Fournier. Today I'm in the library looking for a reference for a new endeavor I'm trying to tackle. I assumed that this would take me a long time, and I felt overwhelmed at first, but then I narrowed down the search and was able to find exactly what I needed. Libraries can be so valuable to help you get off to a great start. I sure wish I could be this efficient in the lab. I dread trying new things because even if I tackle sample preparation and instrument setup, I am still left with manual data interpretation. So in this episode of Behind the Science, let's visit an LC-MS informatics lab, where a scientist I know may have some tips and tricks, or maybe even a glycan library that could help. Hi, Ching, how are you?
Good. Hi, Jen.
Do you have a minute to chat?
Yeah.
So I was wondering if you could help me. I have this new sample that I need to characterize, and I have a feeling that there are going to be a lot of low abundant glycans that I need to take a look at. And the current instrument and sample prep that I'm doing just isn't giving me the right sensitivity, and I'm not able to see those low abundant glycans. Do you have any suggestions?
Yes, I do. So for the sample preparation, I highly recommend using a RapidFluor MS tag. That's a unique labeling reagent that can improve the mass spec sensitivity drastically. And for the instrument, I always use the high resolution mass spectrometry. So in your case, for the low abundant glycan, the high res mass spec with high sensitivity is the perfect tool.
Great. So by combining the high res mass spec, I see you're using the Vion, with the RapidFluor MS sample prep tool, that could give me the best shot of seeing those low abundant glycans.
That's correct.
Great. Do you have any examples of data?
Yes.
All right. Let's take a
look.
look. Great.
Compared to the conventional glycan labels such as 2AA and the 2AB, RapidFluor MS label significantly enhances fluorescent and the mass spectrometry signals. The increased MS signal enables the detection and identification of very low level glycans as low as 0.1% level. In addition, RapidFluor MS improves the collision-induced fragmentation, particularly for acidic glycans in positive ion mode.
Wow, Ching, that was really astonishing data that you showed me. You're finally able to see those low abundant glycans, but my second question is, how do I know what those glycans are?
I have just the answer for you.
Great.
Remember, we have a scientific library called Glycobase Unit Library, and this is what it looks like in this unified software. So in this library, there are different glycan structures compiled, and each unique structure has a unique retention time and accurate mass. So we can utilize this library to look for those low abundant glycans.
Great, let's take a closer look.
There are two unique glycan workflow in unified software that I typically use. The first one is called the glycan FR with MS confirmation. It utilizes this scientific library that I just showed you. First of all, you will perform a retention time calibration using dextran ladder. The calibrated retention time for each dextran ladder will generate this curve. The curve then will be applied to your analyte of interest. So every single glycan peak will have a calibrated retention time based on this curve and an accurate mass measurement from the mass spectrometry data. And then you can combine those two information, follow on with a scientific library search to get the identification assignment. And in addition, each glycan will get quantitative value from the fluorescent signal as well.
Wow, Ching, that is terrific. So if I can combine the sensitivity of RapidFluor MS with a highly sensitive MS instrument, I can finally see those low abundant glycans, and then combining that with the scientific library, I'm able to successfully identify them. Are there any other tips or tricks I need to be aware of?
There's really not much tips and tricks you need to know other than using MS-grade solvent and reagent, because that will guarantee you good quality MS data. That's it.
All right, great. Well, since you already have your system set up, is there any way that you could add my sample to your queue?
We always have time for Jen.
Thank you, Ching. Data analysis is the most exciting part of any process because that is where the answers reveal themselves. We have seen that by combining the power of highly sensitive MS with the increased ionization efficiency of Rapiflora-MS, low-abundant glycans are easier to identify. The advancements we have seen in this glycan series for sample preparation, chromatographic separation, and enhanced electrospray ionization MS is now further complemented with an equally enterprising informatics solution that streamlines glycan data acquisition, processing, and reporting. Data analysis for glycans no longer needs to be so hard. Check out the link below to read more about the data we showed you today, as well as how you can get more information on those label-specific libraries that were referenced. Let's look to change gears. We have learned about tools to help us get information about what the glycans are, but how do we know where they're located? To answer this question, I'm going to put my detective hat on. Join me on the next Behind the Science as we look to investigate this question.